Alright, so I doubt that we're going to get to 531 today. Like, I really doubt it, but some of you like to work ahead and like to try to stay up on the homework. I do not have your math journals done and ready to get back to you because thanks to somebody recklessly ripping out wiring, not me, I got to spend 5 hours with a HVAC person, heating, air conditioning, trying to get the heat fixed in a building that I'm probably going to have to renovate. So it is fixed now. If you have not turned in your math journal, please try to make that happen before the end of the day. I have the bins up here. Your class would not be this bin, but you can be this bin. And I know people were at orchestra, so if you were at orchestra and you missed turning in your math journal, do that as well. But 531 is not really actually homework today. It's just up there if you want to try to work ahead. It'll probably be Wednesday's homework. Tomorrow we will be spending more time working on the mastery because I will be gone at a training. And then if you guys get done with that, I hope to have your math journal to give you, so they'll be on the back table. And I'll be here early in the morning before I have to go to my training. So, sheet of graph paper. And I'm not going to be checking these as notes. This does not have to make it into your math journal. We are just going to do some problems today and practice skills that you're going to need to do move forward. So, I want to play a game. And let's go ahead and put a wager on this. Dum-dums. Let's see who's not a dum-dum.
Hey! I bet you $5.
Alright, so I got dum-dums riding on this. So, please head your paper. More compound events. This one was open. That's kind of gross. Please head your paper. More compound events. And throw a date on there, if you would, please. We're going to play a game that involves two spinners. Spinner A has the numbers 2, 3, and 4 on it. So please, on your paper, depending on how you want to do this, you could say A, 2, 3, 4. B has numbers 6, 7, and 8. Now, you and your partner have to agree, and sometimes that can be a challenge. Now, you know this about the spinners, but when you go to look at them, they look like this. So, you know what numbers are on them, but that's really it. And the rules of the game, that you're going to spin each, add the results, and if the number's even or odd, you will win or lose. So you have to choose, do you want the even results, or do you want the odd results? With this being all that you know, you can make a mathematical decision for why you would pick even or odd. So take a couple minutes, work with your partner. Remember the things that we were working on last week? How we talk about those compound events. I know you don't have your notes, and that's strategic. So you have to remember. If you can't remember what we did, maybe flip back in your book, look at the math notes boxes. I will give you a few minutes to try to come up with whether you would pick even or odd for the sum. And we're going to add the results of the spinners. And you could even, if you want to, imagine it, draw the spinners on your paper or something like that. Could I get a result of a 5?
No.
2 plus 3 are, oh wait. Those are the same spinner. So when you're thinking about results, right, I could do the 2 and the 6, the 2 and the 7, the 2 and the 8, but I can't do the 2 and the 3. How do I represent that? So you're working on your own. I'm just kind of jotting some ideas up here. I think those are the only results that we can get. Alright, you have a minute to decide even or odd. So wrap up your conversation, your decision. What do you think, even or odd? Hey, straight out towards the black SUV. Do not go on the grass. Go out to the left. Do not go on the grass. Pause this. All right. So, all right. If we can refocus. If you'd like to see me jump in my reaction to... Don't worry though, after I jump, then I'll save you guys. Alright, so I know Marvin had a really good idea for what we need to do. So, if your group hasn't figured this out yet, Marvin, how did your group decide to look at the possible results or possible outcomes? Make a table. So if you have yet to do this, let's make a table together with spin 1. And it doesn't really matter, but I'm going to do spin A and then spin B. You could flip these around, but then your table is going to be different than mine, so just realize that. My options from spin A were what?
2, 3, and 4.
2, 3, 4, right? My options from spin B?
6, 7, 8.
6, 7, 8. So now, who needs like 30 more seconds to figure out even or odd? Nobody needs any more time? We're all good? So, like, Ella, what'd you guys pick? Even or odd? You picked even? Emma, what'd you guys pick?
Even.
Bernard, what'd you guys pick? Or French, what'd you guys pick? Even or odd? You never picked. It's okay. If you didn't get to it, that's okay. Karen, what'd you guys pick? Even. Even. Alright, well, I didn't make my pick yet. So, I still need to solve some math. 2 and 6, these are going to be our sums here. Right? But if I know that my 6 stays the same and then these numbers go up, or my 7 stays the same and these numbers go up, I'm really just going up by 1 every time. Right? So this is easy. So if I look for evens, I guess let's call those yellow. 8, 10, 10, 10. How many evens do I have there?
5.
5, sweet. How many odds?
4.
So, please make sure that on this paper, by the way, a lot of these lessons say things like, oh, think about collecting these notes for a participation quiz or things. I'm hoping I don't have to do that, especially since you're not in your math room. I hope you're just working with me, because this is what I'm going to expect on a mastery here in the future, to be able to make these tables and talk about the probabilities. So on your paper, please notate somewhere that our probability of even, we want to write it in that probability notation.
Good morning, Mr. Williams, please come to the office. Mr. Williams, please come to the office. Thank you.
Now here's a tough question. Are we sure? What with what we just did, what are we assuming? Talk to your partner for a minute. With the table we just made, the probability we just made, what are we assuming? No, line paper is okay. I just like graph paper better. It's easier for making tables and everything. I want you guys on your paper to make a new table that says results, but you should spell it right. And you could actually split it if you want to make this easier to look at. You could have an even section and an odd section. And let's play. So, a lot of us picked even. So you guys need to add the results and then write that down in either even or odd. A 3 and a 7, what do we get?
Even.
10. It's an even. So I would put 10 in the even column. Like, go ahead and write the number 10, just because it's useful to see what the results are. Let's spin again. A 3 and a 6. We got a 9, so put that in the odd column. We're going to do this until one of our teams, evens or odds, gets 10 points. At least we're going to try to. 3 and 7. So we got 10 now. Why are you writing these down? Yeah.
Oh no.
Coming at your eraser side. That was like perfect. It flew right in.
It's perfect at least.
Alright, here we go. Another spin. 3 and 6. 3 and 8. 11. Yeah, you guys are writing these down. 3 and 7. 3 and 7. So another 10. 3 and 8. Another 11. 3, 6. There's a 9. I am. You can hear me. 4 and 8. We got a 12. 3, 8. 2, 6. See? There's a 2. We just had a 4. Y'all didn't trust me.
No, we didn't.
It's January. You should trust me by now. All right. Anyone win? Anyone have 10 points? How many? What's coming up? Is even better or is odd better? How many results of each? 6 results of 6 for even.
6 for even, 6 for odd.
Oh, 6 for both.
I have 5.
Maybe you missed one.
11.
I can't keep track on 2 screens at the same time. All right, spin it again. 4, 8. We got 12. 3, 7. We got 10. 3, 8. We got 11. 3, 7. We got 10. 3, 7. We got another 10.
3.
What? Evens 1. Evens got the 10 points.
Yeah,
Evens got the 10 points. Okay. Based off the results we just got, if I asked you to pick an outcome, not evens or odds, but a number, do you think you'd have enough information to make a pretty good choice?
Yeah.
Marvin says 10. Patrick?
10.
Okay. So now this is where the rubber hits the road, which is kind of like where you're actually driving, like, oh, it's real. In fact, the conversation I had you guys have that we didn't then talk about, the table that we made, what did we assume? Alex? That all the pieces were equal. Based off our spinner results as we spun this, do we think all of our outcomes are equal? What outcomes seemed more prevalent than anything else? What was like happening so often it was almost frustrating? Alex? The 3 on the left spinner, right? So what if I actually show you that's what that spinner looks like? And what if I actually show you that that's what that spinner looks like? So I want you to make a new table. Hold on. I want you to make a new table with the actual probabilities of first each result on each spinner, and then the probability of each sum. So first thing you want to do is go around and say, what's the probability that this spinner gets a 4? What's the probability this spinner gets a 2? What's the probability this spinner gets a 3? And so on. Then you want to make that table that we just had, but remake it with the individual probabilities of each outcome. So you're not looking for one probability of 10. You'll have multiple probabilities of 10. Take a couple minutes to work on this. Alan, on spinner A, what's the probability of getting a 2?
Wait, is it in percent?
Fraction. You want to look in fractions? It's easy.
It's 1
One how much?
30.
So if I imagine this slice, I gotta make everything equal sizes. How many total slices would there be then?
8.
So how many slices does 2 get? One of them. So this is 1/8. So if you're setting up your table, you want probability of 2, have 1/8. What about the probability of 3, Renard? What's your chance of getting that 3? How much of the spinner? Yeah, 6 out. How many? 6 what? 6/8. Now you could simplify it as 3/4, or you don't have to. You could leave it as 6/8, since we're working in eighths with my other fraction. This is nice. Nathan, what about probability of 4?
You made a mistake. It
What?
should be 6, 7, 8, not 7, 8, 9.
6, 7, 8 is over here. Thank you, sir. I'm not quite remembering when I was building this. Do you know what the probability of 4 is?
1/8.
Yeah, because it's that same size slice. Any questions on how I got those probabilities? So then, Penelope, what's the probability of getting a 6?
I don't. It's
How much of the spinner is a 6?
1/3.
A third, right? What about 7?
1/3.
What about 8? So all of those are equal probabilities. 1/3, 1/3, 1/3. I want you guys to take a minute to figure out what's the probability of each outcome. If your team thinks you have it, come up and verify it. So not each spinner, but the outcome of the game. What's the probability? So we said our options were like 8, 9, 10, 11, 12. It's like, what's the probability of 8? What's the probability of 9? What's the probability of 10? What are those actions? Now with the information that we know. Because the table we made before wasn't quite right. Actually, let's do this. I'm going to give you 5 minutes. I'm going to clock it, and I'm not going to like help you or do anything. I'm going to give you 5 minutes to really, the question you're trying to answer is now with the information that we know, what's the probability for even and for odd? But I kind of already gave it away that to get there, you're going to find the probability of each individual outcome. 8, 9, 10. A new table. Unless you had plenty of space to modify the old one, you should have a new table for this situation. Is that a probability? You can have a probability of 1. Plus. If I look at making a 12, what needs to happen? If I look at making a 12, I know I lied, this hasn't been 5 minutes, but even just a quick pass of the room. Alright. Monica's gone. Francesca. If I look at making a 12, what do I need to have happen to get 12? 4 and an 8, right? There's only one way to get a 12, a 4 and an 8. What's my probability of getting a 4? What's my probability of getting an 8? What does that make my probability for summing a 12? Think back to if I want to roll a 3, flip a heads. How do I deal with compound probability? One event and another event. Do I add these fractions or do I multiply these fractions? Is it harder or easier to get two things happen? To get two things to happen compared to just one thing to happen? Which is harder? It's harder to make two things happen, right? If I only want to spin the 4 and I don't care what happens here, that's fairly easy. But now if I care what happens here, it gets harder. We multiply. So on your notes, you might want to jot somewhere the sum of the and situation is going to be 1/8 times 1/3, which makes 1/24. So your probability of that 12 right down here is a 1 out of 24. I will still put up the offer. First group that can tell me, you can just raise your hand, I'll come by. Even or odd, and the mathematical defense behind it, prize on that. So people are going to give you guys the time that I did not give you. Anybody think they have it? Probably even and odd and new ones. They're not equal chances. I'll tell you that. No, you gotta give me a combined. So what is the new probability of even and the new probability of odd? No, so guys, you should have this new table set up. Notice the next thing that we're talking about. What's probability of even? What's probability of odd? So I have it set up, ready to go. So if I start filling in this table, and most of us have the table filled in, I, again, would advise for you to have the result in the box as well as the probability. Like, what's the probability of this 8? So you guys can shout it out.
4.
This 9?
6/24.
6/24. So I'm going to leave that unreduced, actually. And 10? 1/24. What about this 9?
1/24.
And what if I just drop straight down?
1/24.
Yeah, those stay the same in the column. What about this 10?
6/24.
This 11?
6.
This 11?
1/24.
Interesting. So if I look at the probability of even. Now I don't care about that top part because I only care about what's in the table. Nathan, what'd you do here?
For even, the probability is 5/24, and for odd, the probability.
Wait, how'd you get that?
I added up the evens, like, I added up.
Okay, so I'm going to highlight again because highlighters are our best friend. So 1/24, 1, 6, 1, 1. You said you got how many 24ths?
5.
I think you might have an error. Alex? We look at 1, 2, 3, 4, 6 more right here. My probability of even is this 1/24 plus that 1/24 plus that 6/24 plus that 1/24. It's all of these put together. So for my probability of 8, I've got 1/24. My probability of 10, I've got 8/24. So I'm going to write this out, guys. I had 1/24 for the 8 plus 8/24 for the 10 plus 1 more 24th for the 12 that we got down here, and that gave us 10/24. Now before, y'all told me that even was the better choice. Is it looking like even's the better choice? Kate, what'd you get for odd, or how'd you figure that out?
14/24.
Ah, 6, 12, 2 more. So if I were to write this out, my 9s gave me 7/24, and my 11s gave me 7/24. You do not always have to reduce. Notice up here, give me your eyes for just a second, I didn't reduce at all. Things that would have been very easy to reduce. Reason is it kept them all as common denominators. I like that all of the denominators up here were 24s. It made them easy to work with. Okay, so even though, and this is sometimes like some of my quicker math students was like, oh, reduce that. Well, not always. Like, take a moment to breathe and think, do I need to? You don't need to. Don't spend your time doing stuff you don't need to. Questions on this? Do we all understand how we now see that odd has a better chance? If I had shown you this from the get-go, do you think you would have been able to say that odd had a better chance? Maybe. But now we can mathematically defend exactly why. You guys are just so excited about this problem, you can't stop talking about it, right?
Yeah.
Exactly what's happening back there. All right. There's one last little challenge that we were going to do for this lesson, but my smart word is not working. We fixed all this. So, we have about 4 minutes. Elliot loves listening to music, and he listens on his shuffle. Right? If you remember the iPod shuffle. He has songs stored in 4 categories: country, blues, rock, and classical. 2/5 are country, 1/6 are classical, 1/3 blues, rest are rock. What's the likelihood that his first 2 songs will be country and then a classical? Or either a country song and classical will come up first? We're comparing the order mattering. So your first option, I'm going to write this out. So A is asking, what's your chance that song 1 is country, then classical, and the option B is just saying country or classical? Think about that for a minute. How do these differ from each other? Yeah, like, I mean, they're not going to be the same answer, right? Because they're 2 different situations. So we doubt they'll be the same answer. Delaney, what's my probability of getting a country song? Were you guys working on this back there? Alan, what's country? Sorry, Delaney, we're just running out of time. You gotta go quick. Probability of classical, just shout it out. 1/6. What do I do if I need the country song and then the classical song? I need the one to happen, then the other. Okay?
Add them and you need to find a common denominator.
Do not actually. Here, for country, then classical, I have multiple. Because when I need one and then the other, that's 2 events, right? Like the spinner, I need to spin a 4 and then spin an 8. I need to get a country and then get a classical. So we, Nathan? Yeah, so what do we get? So hold on, so we get 2/30ths for that probability. 2/30ths or 1/15 if you want to reduce. The OR situation. Sorry, I'm wrapping up, I promise. The OR situation adds them. So please just get written down. Because it's OR and we don't care which, the probabilities add with each other. And we'll do more of this as we go. So tomorrow you're going to get more opportunity to work on your mastery. Please make sure this all makes sense. Have a great day. What? 2:15. Oh. Thank you. By the way, your homework should already be done. Like, you shouldn't have any homework to do, really.